Imagine a power so immense it could rival the stars themselves. Not the gentle twinkle you see in the night sky, but the raging, furious heart of a sun. This is the power of the hydrogen bomb. It is a weapon born not just from human ingenuity but from our ambition to unlock the deepest secrets of the cosmos. For millennia we looked up at the sun and saw a god, a source of light and life. Then in a terrifying flash of insight we learned to steal its fire. We learned to build a star on Earth. But this was no act of creation. It was the ultimate instrument of destruction, a force capable of erasing cities, nations, perhaps even our own future from the pages of history. Our story begins in a world fractured by war. The flames of World War II had engulfed the globe. In the shadows, a new kind of conflict was taking shape. It was a war fought not with soldiers on battlefields, but with minds in laboratories. The world's most brilliant scientists were conscripted into a top-secret race, a desperate sprint to unlock the power hidden within the atom. They worked in clandestine facilities, hidden away in remote deserts and secluded mountain towns. Places like Los Alamos, New Mexico became silent epicenters of a scientific revolution. This race was fueled by fear, the fear that the enemy might get there first. The Manhattan Project, America's colossal effort to build the first atomic bomb, scientists who had fled the tyranny of Europe now dedicated their lives to creating a device of unprecedented destructive power. So, what is this superpower? How do you create a weapon that dwarfs the already terrifying force of an atomic bomb? The answer lies in mimicking the stars. The sun, and every star you see in the night sky, is a gigantic fusion reactor. For billions of years it has been turning matter into energy, bathing our solar system in light and heat. It does this through a process called nuclear fusion. At its core, the immense pressure and temperature are so extreme that they force the nuclei of hydrogen atoms to slam together and merge. Think of it like this: imagine trying to push two powerful magnets together by their identical poles. They resist, they push each other away with incredible force. Atomic nuclei behave in a similar way, their positive charges repel each other fiercely. To overcome this repulsion, you need unimaginable conditions. You need temperatures of millions of degrees and pressures that crush matter into a superheated plasma. On Earth we had to find another way. We needed a trigger, a match to light the fusion fire. And that match was another nuclear bomb. The secret of the hydrogen bomb is that it's a two-stage weapon. The first stage is, in essence, an atomic bomb like the one used in World War II. This is a fission bomb. It works by splitting heavy atoms like uranium, plutonium, apart. This splitting process releases an intense burst of X-rays and heat. This is the trigger. This initial explosion creates for a fleeting microsecond the hellish conditions to ignite the second stage, the fusion fuel. It creates a temporary, man-made star core right here on our planet. In that second stage, the real power is unleashed. The fusion fuel, typically isotopes of hydrogen called deuterium-tritium, is compressed and heated by the fission explosion. The hydrogen nuclei, stripped of their electrons and moving at incredible speeds, are forced together. They fuse. The theory was elegant, even beautiful, but the reality was monstrous. On November 1, 1952, on the remote Elugelab atoll in the Pacific Ocean, the device, codenamed Ivy Mike, was not a deliverable bomb. It was a colossal multi-story laboratory, a cryogenic behemoth filled with liquid deuterium weighing over 80 tons. At the moment of detonation, the world held its breath. Then, in a silent, blinding flash, a new sun was born over the Pacific. A fireball 3 miles wide swelled into the sky,